set up the icebox thingy, which you already did, and just gonna write this down. 3 COOH is 3 CO minus plus hydrogen ion, and yeah, beginning change and equivalence point. Now some of this has already been neutralized by this, so we must find the concentration of the remaining uh, exit. I'm gonna calculate that out, but you get the idea. And this we already find, which is the concentration of the base. So, and this we don't know yet. We don't have it yet. So it's after some time it's gonna dissociate. We have this. So after a while we have sort of whatever that is, and we have whatever this is. And again, we have to find this based on the Ka value of this. So Ka in this case should be plus x should be something like plus x times x over concentration of this minus this. Now, because again, we don't want to complicate this problem, so we're gonna eliminate these kind of things and making it easier for us to find x. And since the x is always, I think, usually really small compared to these types of concentration, and this is like concentration of the acid, this is concentration of conjugate base, so we find x equal something based on this, and then we find concentration hydrogen ion, which is x, and then find a pH, which we already know. Alright. Now, so what happens at equivalence point? Well, what happens is that all of this will be neutralized by this, but we still have the conjugate base of this, which still has some effect on the pH of the solution. So we can't say that pH is equal to 7. No, you can't say that. So what we want to do is to find the concentration of the remaining of the conjugate base. In this case, it's 0.1 molar times 50 milliliters over 100 milliliter. And yeah, this is the concentration of the conjugate base. And after finding the concentration of the conjugate base, we want to set up a sort of icebox table, but this time we use the Kb value of the conjugate base, and this can be calculated by dividing the Kw, which is the water dissociation constant, over Ka of this weak acid. And we all know that this is 10 to the negative 14 over blah blah blah, and we find something. And so that's what we want to do. Now we're gonna set up a similar icebox table, but with conjugate base instead, because that's what we all have now in the solution. That's all we have, and it's gonna react with hydrogen of water, in solution to go back to get a sort of solution, sort of equilibrium of So 3COOH plus OH minus. So again, beginning, chain, and equilibrium. Now we already find the concentration of conjugate base after doing some stoichiometry work in this. So I'm gonna put it at this, and we don't count this at all. And since it does not at beginning, it does not dissociate into this yet, so we gotta put this at 0 0. It's plus x minus x, we have x, and I'm just gonna assume that x is negligible according to this, so just put as that. And oops, sorry, my mistake. And it should be this. Now what we want to do again is to find the x, but in this case the x is the concentration of the OH minus, because what we have left is a conjugate base, not the original weak acid we have. So what we're gonna do is just find one more step based on this. You have POH, and then you have pH, which is equal to P negative 14 subtract by POH. So that's done. And now the last one is pretty easy, and it's kind of the same with the strong acid, strong base titration, which means that when this is in excess, we only need to find the remaining, find the concentration of the excess NaOH. So after that, you find concentration of hydroxide ion based on this, and because it is a strong base, so we don't have to base on any kind of Kb value, and we have OH minus, so we should be able to find pOH easily. In this case, we find pH. So pretty straightforward. Now, to sum it up, I'm gonna give you some sort of my strategy on things, and I did this already. So before titration, the only thing you need to do is find the concentration of strong acid. Oh, this is strong acid, strong base titration problem. Find the concentration of acid, or if they give you already, then it's great. And that concentration of acid is also the concentration of hydrogen ion, which we will use the pH definition to find the pH based on the concentration of hydrogen ion. Now, when it's only before some base is added, but it's not going to go to equivalence point yet, then we subtract to get the remaining mole of acid, find a new volume, find a new concentration of acid, and it will get you to pH. And at equivalence point of strong base and strong acid, strong base titration, the pH is always going to be 7. And after equivalence point, or if there's an excess base, calculate the more excess base, find new volume, find the concentration of the base, find the which will get you concentration of hydroxide ion, get pOH, and get pH based on that. And this is sort of my strategy for the weak acid, strong base. Before you go to titration, we use the weak acid dissociation constant for this, and we set up kind of a table where this is for the concentration of the remaining acid. This is the concentration of remaining acid after we doing some stoichiometry work with the base. So this is what we set up. We find the X, find the concentration of hydrogen, and then we find the pH. Next up, this is after some base is added, and oh, find some bases added, and I'm sorry, I made a mistake. This is where the concentration of the acid itself, because this is before titration. So there's no base going on yet. So this is the concentration of the acid itself. Sorry. And in this case, this you have to find it by find the remaining hydrogen of the acid after some base is added. So we will put that into here, and we'll find the concentration of the conjugated base based on what we already calculate in the stoichiometry problem when base is added to the acid, and we sort of find similar to before titration, and we find this. Now, and what happens at equivalence point is firstly you have to find the concentration of conjugate base form, and then you based on the Kb value of conjugate base, and by using this formula and find concentration of conjugate base, set up this type of iceberg problem, assume that this is negligible according to this, and find the concentration of the OH, and then you find POH, and then you find pH, and after equivalence point excess base, it's just basically the same. Okay, so I hope you guys find this sort of helpful, I believe, but it's sort of what I usually deal with. I mean, you can also use the Henderson equation, which is the I think pKa equals to sorry, pH equals pKa plus logarithm of the conjugate base over the concentration of the acid. Well, you can use this, but I usually use this myself, but if you want to do a more concrete way of doing this, you want to do sort of the traditional way, then I already shown you, and this is just like an extra. And since this video is too long already, I'm gonna stop myself here. So yeah, I'm hoping everyone is enjoying AP Chem, and I enjoyed it myself. Miss Baxter is a really great teacher, and yeah, so good luck. Bye.